So today, Unit 5, Lesson 1, Investigation 3. I wrote reverse FOIL, but it's really factoring trinomials. Now we learned about binomials. What is a binomial?
Two numbers.
Has two numbers, right? Something has two terms in it, right?
Right.
Okay, what's a trinomial? Three terms. You guys are smart. Binomial, two terms. Trinomial, three terms. Which equation up here has a binomial in it?
B.
A. A has binomials, right? Two terms. That means B is a trinomial. What we're going to learn today is how to take something that looks like this and rewrite it like that. Because you guys already know how to go from here to here. Yep, what process? FOIL. Good. If you FOIL something that looks like this, then you'll get something that looks like this, right? Right? So if you FOIL, you get that. So we're going to reverse FOIL or unfoil. We're going to take the pizza out of the aluminum foil. Life? Okay. We should call this life. All right. Any questions before we get started? Okay. Now equation A and equation B make a graph. If I were to put those in my calculator, and you cannot do that because I use letters. If I were to put those equations in my calculator, what would they make? What would A make? Parabola. Good, Bruno. What would B make? Nope. Well, we just talked about how if I foiled this, we'd get that, right?
Yeah.
So is it really changing the equation?
No.
Just changing how I wrote it, isn't it? So we still get a parabola. So both of those equations give me a parabola. They're actually the two forms of a parabola. This one is called the factored form because it's made up of binomial factors. This one's called the expanded form because it's a trinomial. It's bigger. Okay. Now both of these forms have benefit. Okay. They both have, it is beneficial to write a parabola in either of those two forms. Okay. So A is the factored form. B is the expanded form. Hey, look. FOIL factoring. Okay. So if I have y equals A times x minus m times x minus n, and y equals ax squared plus bx plus c. What's the benefit of this form? What do I know right now? What do you mean what everything is? Your x, your y. Okay, what are m and n? X-intercepts. So this equation, once in factored form, the benefit is it tells me right now what the x-intercepts are. So if I had to build a parabola with a certain x-intercept, with two specific x-intercepts, I can plug those in for m and n, right? Right? So it tells me what the x-intercepts are. The x-intercepts are m and n. That's the benefit. Just by looking at an equation in that form, you know the x-intercepts. Right? Have we done that before? Have we done that before? Was that a yes? Okay. Other equation. Ax squared plus bx plus c. What do we know right away? We don't know m and n. This one. I'll give you a hint. It's an intercept. The y-intercept. Which one? What is it? Not the b and the c. Just the what?
C.
Just the c. Okay? The y-intercept here is just c because if I'm at the y-intercept, remember I told you the other day? The one thing you need to make sure you learn from this unit is at the y-intercept, what value is 0? Andrea? X. At the y-intercept, x is 0, right? So if x is 0, that means this isn't there, and that's not there, right? All we're left with is c. So that tells me that the y-intercept is c. So the benefit of that equation is if you need to design an equation with a certain y-intercepts, then you might want to start with this one. Does this make sense, guys? Maddie, you remember the m and the n thing? Yeah? Okay. Same idea if I'm in mx plus b form, right? The thing with the x was the slope. The thing by itself is the y-intercept, right? Just the different letters by itself now. So that's our y-intercept. Whatever doesn't have an x on it, guys, that'll always be the y-intercept if it's added. Another thing about this is the b actually tells us the slope when x is 0. So b equals the slope when x is 0. So what that means is if b is positive, then the parabola will have an increasing slope as it crosses the y-axis. If b is negative, then the graph will have a decreasing slope when it crosses the y-axis. Now we're not really going to get into that much in this class, but I think it's worth telling you. Last thing, a is the same in both. Okay. What does a determine for both of these? Nope.
The maximum.
Okay, good. It opens up or down, right? If a is positive, which way are we facing? Up, right? Opening up. If a is negative, which way do we face? Down, right? We open down. Does that make sense, guys? Yeah. Are there any questions? Okay. So the goal for today is what's called factoring trinomials. Oops. Factoring trinomials. And when you factor trinomials, what do we get? We'll get two binomials. Okay? So factoring trinomials into two binomials. That's what we're doing today. Okay? So we're going to take something that looks like this.
Is it all going to be on the test?
Yes.
That one and that one? Yeah. All of them? You like?
Okay. We're going to take something that looks like this and rewrite it like this. So reverse foiling. Okay. What?
I barely know how to do that.
You barely know how to foil?
Yeah.
You learned foil last year. I know, you need to remember things. Math builds. Okay. So, how will we do this? We'll use what's called what I call the box method. Okay. I would call it the Punnett square method, but I think a lot of you would then get confused with science and want to do recessive and dominant traits and stuff like that. So I don't want that to happen. Right? So this is the box method. I know some of you guys have already written this down, right? But we're going to go through this method as we factor this trinomial. Okay. So that trinomial is on your paper, right? Okay. So hopefully you have them all written down. Got them all written down?
All the steps?
Yep. Okay. You have that little box thing filled in?
No. You told us not to.
I did?
Yeah.
Oh, I'm
Someone
sorry.
asked you if they should fill in the box. You said no. We'll do that later.
My bad. My fault. Okay. So fill the box in. So x squared, hashtag bx, and c. Hashtag, yep. The reason why I use hashtag is I want to think of a symbol that I knew you all knew. Okay? Yeah, you used to call it pound sign. Or number. Okay. Now, let me explain for a moment what the hashtag bx is. Okay? Look on here. It says find the factors of a and c that add to b. Okay? So, hashtag is not a mathematical operation. It's just how I'm denoting two factors that we're adding together to get to b. Alright? So that'll make sense as we go through it. Alright? Hopefully. If it doesn't, excuse me. If it doesn't, then I need to explain a little bit better. Alright, so x squared plus 5x plus 6. Alright? Now, right now, it wouldn't make a graph because we don't know y equals, but this works for anything. If I put a y equals in front of that equation, it doesn't change a thing. Okay, everything we're doing can still be applied. Alright? So, what's the first step?
Find the factors.
Nope. Multiply a and c. So you're probably saying, whoa, I don't see an a or a c.
I do.
6 is
x squared is 6.
In the general form, y equals ax squared plus bx plus c. Right?
Yep.
So what's the a value?
1.
1. It's whatever's in front of x squared. Since there's nothing there, it's a 1. Right? So a equals 1. What's the b value? 5. Good. What's with the x? Okay. What's c? 6. Okay. Does that make sense? Okay. Step 1. Multiply
1 and 6.
a and c, right? A and c. What's 1 times 6?
6.
And you guys are smart. Okay. 1 times 6 is 6. Step 2. Write down the factors of a times c. A times c equals 6, right?
Yeah.
What are the factors?
1, 6, 2, 3.
1 and 6, 2 and 3. Any more? No. Step 3. Find the factors of a times c that add to b. Okay? Find the factors of a times c that add to b. So I want to find the factors here that when I add them together we equal what? 5. What's 1 plus 6?
10.
7. Is that the right one? What's 2 plus 3? 5. So these are the factors I need. Right? Does that make sense?
Wait, is it going to be like all?
Okay. So remember on those steps, I told you to do this.
What's that?
Okay? You already wrote it down? Ax squared plus hashtag bx plus hashtag bx plus c. Right? You didn't write that down long? As part of the steps you were supposed to copy down already? Remember we did at the beginning of class? You didn't write them down? Oh my goodness. Copy Tony's then. Alright, I'll put them back up there later. Alright, so this hashtag bx and hashtag bx, what numbers are those? What numbers? They're the two numbers that add to b, right? So what are our two numbers that add to b? 2 and 3. Okay. So that means I'm going to take this in step 4 and rewrite it like that. Okay. Does that make sense, guys? How long can you go? There's the rules again. Okay. So we multiply a and c. We listed the factors of a times c. We found the ones that added to b, which was 5, and then we rewrote. Okay, does that make sense, guys? The hashtag is just to note that those are the things that add to b. If you don't want to, it's fine. But I don't want you to write 5x plus 5x. Because if you just write b right here, then you probably will end up writing 5x plus 5x. Okay? So I'm just using the hashtag to denote those are the two numbers that add to what b was. Okay, does that make sense?
And they have to be a factor of.
They have to be a factor of 6.
Okay.
Yep. So we cannot use 1 and 4.
It's always gonna find a pair that.
If you do not find the pair in here that adds to this, then it's not factorable. Okay, which is possible. Okay, but right now it won't happen. Okay. All right, have all the questions answered? So let me repeat what Faith asked. Faith said, "Well, we always find a set of factors that add to b." And the answer is no. When you do not find a set of factors that add to b, then it's not factorable. You're done right there. Okay, so now you're all probably hoping for that to happen. Okay. All right, any questions about how we got to here? All right. So now we draw a box. Doesn't need to be as big as the boxes that you have on your paper. You just draw a box. Okay. In this box, we write what? The ax squared term, right? So in this one, it's 1x squared. Or x squared. In this box, we write one of our hashtag bx's. It doesn't matter. I can write 2 here, I can write 3 here. It does not matter. Okay? Look at 2x. This one I write 3x. And this one I write 6. Okay, so we filled in the box. Does that make sense? Okay. Step 6, find the GCF of each column. What is GCF?
Greatest common factor.
Greatest common factor. So I want to find the greatest common factor of each of these columns in each of these rows. Columns, rows. Okay? Now, you might not be able to do this just off the top of your head. So there's probably some space left in your boxes. What you can write in your boxes, you can write down the factors. Like 6, we have 1 and 6, 2 and 3. Okay? This we have 1 and 2, right? This one's just x and x. This one is 1 and 3, right? You can write those factors down if you want to. You don't have to, but you can. Right? Now, greatest common factor in this column, x squared and 3x. X. X is the greatest common factor. Does that make sense? Greatest common factor in this column. 2. Good, that 2 looks funny. Greatest common factor in this row. X. Greatest common factor in this row. 3. The 3 and the 2 are both positive, right? Okay. So we have 6 done, right? Take the left side and the top, and they make up the binomial factors. So that means that the binomial factors are x plus 3, x plus 2.
Wouldn't it be minus?
Nope.
Why not?
Why would it be minus?
Because they're both positive.
Right. Positive times positive is positive, isn't it? Where's subtract?
The binomial isn't the binomial.
X minus m. X.
Oh, so this?
Yeah.
So this means that your x-intercepts are negative 3 and negative 2.
But they're not negative.
Wait, those are just the factors. So these are just the factors. The factors aren't negative because the 6 is positive.
Yeah, so why would you put them, like, I thought if they were, when we did binomials, like last week or something,
Yeah.
you told us if you put a plus sign, then that means they're actually negative numbers. If you put a subtraction sign, then they're actually positive.
That was for finding the x-intercepts. So if I had like y equals in front of this, then that means that this x-intercept is actually negative 3. And this x-intercept is actually negative 2.
Oh, so you're not going to put them in the equation?
Nope. So right now we're just trying to factor. We'll get back into those intercepts later on. Okay? So this is just factoring. Okay. All right, does that make sense, guys? Seem easy enough? Yeah. Now we had only addition here, so we do not need to worry about negative factors. If we had subtraction, which we'll do an example here in a little bit, if we had subtraction up here, then we would have to worry about negative factors. Okay. Any questions before we try another one? No? So here's a whole bunch of practice problems, right? Don't worry, Faith, we won't do them all today. You might do some tomorrow. I'm sure. What? No, tomorrow. I know tomorrow's Saturday. Yeah, I'm a mean guy like that. Alright, so let's try A. So A is x squared plus 9x plus 18. Write that down real quick. X squared plus 9x plus 18. Okay, I want you guys to try to figure out what the A and the B are and the C. I'm going to write the next one over here. So we're going to do both of these. So the first one, x squared plus 9x plus 18. What's my A? 1. What's my B? Let's see. Step 1 says to find, Step 1 says to multiply A and C. So A and C, 1 times 18, right? What's 1 times 18? 18. Step 2. Write down the factors of 18, right? What are the factors of 18?
1, 18, 2, 9, 3, 6.
I sound so happy when you're doing that. 1, 18, 2, 9, 3, and 6. Step 3. Find the factors that add to
9,
9.
3, and 6.
Good. 3 and 6 add to 9. Okay. Now we rewrite. So x squared plus, no, 3x plus 6x plus
9.
18. Right? We just break the 9x into the two factors that add to it. Okay. Does that make sense? So now we draw our box. What goes here?
X squared.
3x. Could be 6x too, doesn't matter. 6x, 18. A and C always go here. These ones are the factors of B. Okay. So, top row. What's the greatest common factor? Greatest common factor right here. X. Right? Yep. What's the greatest common factor here? 6. What's the greatest common factor here? What about here? 3. So that means our factors are x plus 3 and x plus 6.
Is that it?
So now if I were to FOIL this, what do you think we'd get?
X.
So we're backwards FOILing. Does that make sense, guys? Okay. Now last hour they were trying to work out some shortcuts. Like, oh, we don't have to do all that. You just look, you get 3 and 6 every time. It just goes in, it works. Right? The reason why these factors are turning out to be those two numbers in both the ones we've done so far is because our A is 1. Okay? This method is to work every single time. Okay? The idea that you just pull these factors out only works when A is 1. Right? So I'm trying to teach you a method that works every single time regardless of the A value. Alright? Does that make sense? So please do not try to shortcut this. Alright? Make this second nature. I guarantee that one of these will be on the ACT. Okay? Maybe more. Alright. B. What's our A value? 1. What's B? Good job. -4. What's C? 3. So because we're subtracting here, B is -4, right? Alright. Step 2. Nope, step 1. Multiply A and C, right? What's A? 1. What's C? 3. 1 times 3 equals 3. Good. Factors of 3.
1, 3.
Oh, 3 is a prime number, huh? 1 and 3. Dave, you paying attention?
Yeah.
Okay. Does 1 plus 3 equal -4? No. Doesn't work, does it?
So we're done?
Okay, no. Because there's also the negative factors.
Wow.
-1 times -3 also equals 3. Okay? Whenever you have a subtraction sign, whether it's here, or in both places, you're going to need to use the negative factors. Okay? Does that make sense? Now, if this 3 were negative instead of positive, then I would have to have one negative sign in each factor. So it'd be like -1 and 3, -3 and 1. Does that make sense, guys? Yeah? Okay. So, Does negative 1 and negative 3 add to negative 4? When I add these together, do I get negative 4?
Yes.
Kendra, does this make sense? Okay. So what that means now is that my negative 4 becomes negative 1x, negative 3x, plus 3. Does that make sense, guys? Does that make sense?
Yes.
So draw our box.
Well, since x is and a is 1.
X squared goes there, right? Negative 1x, negative 3x, 3. Okay. Now, what's the greatest common factor between these ones? X. What's the greatest common factor between these ones? 3. Right? What's the greatest common factor between these ones? X. What's the greatest common factor between these ones? 1. Now, I'm going to caution you just a little bit. Because this tells me that my binomials are x plus 3, right? And x plus 1. Now, you guys have all foiled enough times to see a problem here. What's the problem? I won't get negative 4, will I? Okay. So what that tells us is if I have negative numbers here, I need to include negative factors here, right? Right? And if I have a negative greatest common factor, then we need to use it. Okay. So what that means is if I have 1, 3, those are 2 factors, right? I also have negative 1, negative 3. Okay. If this number is negative, then I need to include that negative sign in the greatest common factor. Does that make sense? Okay. If this number is negative, I need to include that negative sign in the greatest common factor. So now instead of addition, these are subtraction. Does that make sense? Are there any questions? You guys have just learned in like 30 minutes by the most difficult thing that plagues most high school students. Okay? Plagues. People don't like it. Okay. So it's not, I mean, it's some steps, but I think it's very, very usable. Okay? Try to make it as easy as possible. All right, guys? I know multiple ways to do this. I'd say this is probably the easiest way to factor. Okay? Of all the ways I know how to factor, this one is probably the easiest. All right? All right, are there any questions? Any questions?
No.
None?